If you like these videos, please check out my full course at www.lsat.totaltestprep.net with tons of clearly explained actual LSAT questions written by someone who's mastered test and helped others master it, and an evaluation period where you only pay if you want to continue.
Okay, so in this video, we're going to go over the complex structural games. So, what are the basic aspects of complex structural games? Well, the complex structural games will have multiple structural sets. So, what are the characteristics of the movable and structural elements? What are the characteristics of their interaction? What are the characteristics of the rules? Okay, so let's take a look at this. So in terms of just the movable and structural information, we have our game here on the right. We have the tourists, A, B, C, D, E, and F. They've booked rooms in 3 bungalows, X, Y, and Z, and each bungalow has 2 rooms, 1 and 2. So this is slightly more complicated. So all of a sudden we have more information here than we did in the previous examples. We have tourists, we have the bungalows, and then we have the rooms. So there, it seems like there's 3 sets of information here. Now, before I get to how I drew it and what I chose down there, what you see is similar to what I had in terms of a column, but now I've added rows. Before I explain all that, let me go into a little bit more detail into what's going on here exactly in terms of the difference between the basic games and the complex games, and what is special or what is specific to the complex structural games. So, you're always going to have one movable set and 2 structural grouping sets. So that's the way this works. You're going to have, it's still the same thing, so it's still movable structural, but now you have an additional structural set. So you're essentially putting each movable element into 2 groups simultaneously. Okay? And that's kind of what we see here. So we see that we've got the 3 sets. We've got the tourists, the bungalows, and the rooms. And the choice that I made in terms of how I chose to diagram it, I chose to have the tourists, as the movable elements, and then the rooms and the bungalows, so bungalows X, Y, and Z, and rooms 1 and 2 as the structure. So they make up my grid. So I have columns and rows here. In here, it's not just the columns that are the structure, it's also the rows. Now, how did I get to that? Well, we'll clarify that in a second. But that's what I have here. I'm moving the letters within that grid, and that grid is now my 2 structural sets combined. So there's 3 possible variations for these complex structural games. So you can have structural grouping sets that are not in sequence, and that's kind of what we have here. There's no sequence involved here. So we just know that there's bungalows X, Y, and Z, and we know that there's rooms 1 and 2, but we don't know where X is and where Y is. It's not like the bungalows are in a row or the rooms are in a row. So there's nothing dealing with sequence here. But we still have the 2 structural groups in sequence. The other variation is that one of the grouping sets in sequence. So imagine we said that the bungalows X, Y, and Z are in a row along the road. So they go from west to east with X all the way down the west, Z all the way to the east, or whatever it might be. That would be where there's sequence. Or you could have both grouping sets being in sequence. So you can have both let's say that there's a north and a south room, and then these bungalows are east to west. So that's a possibility as well. So those are 3 possibilities: either no sequence whatsoever, only one of the structural sets gets a sequence, or both sets get some sort of sequence. And I had mentioned this in a previous video, but when you have days of the week and times of day, that is a very common way in which you have 2 structural sets that both have a sequence. Okay, so these are the basics in terms of what we have in terms of the variations. Now, the other thing to remember is that there's always going to be only one movable set. So in this case, we have the tourists. They're the only ones we're moving around. We're putting that into this grid. We're putting that into the horizontal, and rather into the rows and into the columns. So the movable elements are generally going to range from 5 to 8, and sometimes you'll have what I call binary movable sets. That just means that you're given one of 2 options. So it might say something like a rich and a poor tourist. There's a rich tourist and a poor tourist, and they get these bungalows and these rooms. You don't know how many repetitions of each one you're going to have, but you have one of 2 possibilities. More rarely, you have one of 3 possibilities. So for those, you're going to have a repetition of the elements, because there's only 2, sometimes only 3. and you won't know which one's going to repeat it and how many times. But that sometimes happens, and we'll see that in the exercises. And another common variation is where the movable set is actually duplicated. So you might have here like 3 tourists, and they've booked 2 rooms. And so, you know, the tourists A, B, and C, they'll book room 1 in X and book room 2 in Y, or something along those lines. So you're actually, depending on how many say rows you have, you'll have a repetition of that movable set in each row, for example. So this, we'll also see this in the exercises, but you can have a situation where you are reusing, but you know exactly how many times you're reusing, and you're reusing all of the movable elements from the movable set. And sometimes you'll encounter subsets, and sometimes, once again, a bit more rarely, you'll have combination sets. Likewise, the structural set is a column with rows, and that's what we have here. X, Y, Z are the columns, and 1 and 2 are the rows, and it's best represented as a grid. And it's generally going to be 3 or 4 columns and 2 or 3 rows. So you're going to have generally anywhere from a 2 by 3 to a 3 by 4, or like might be 2 by 5, or sometimes even a 3 by 5 grid. Now, how do I identify that? How did I know that those were the bungalows and the rooms were the 2 structural sets? Well, what I have here is, to identify the grouping sets, you look for the all-to-all relationship. Now, what does that mean? Well, look what I have highlighted here. It tells me, the game tells me, that each bungalow has 2 rooms. Okay, so what that means is that whenever I'm trying to figure out which bungalow maybe gets which rooms, I know for a fact that every single bungalow, that X is going to have something to do with both rooms, Y is going to have something to do with both rooms, Z is going to have something to do with both rooms, and vice versa. Room number 1 is going to be a room number 1 is going to be in X, in Y, and in Z, and the same thing with room number 2. That's what I mean by each to each. The difference between the tourists is that some of the tourists are going to go in bungalow X, and some of the tourists are going to get room number 1 in each bungalow, but not all of them. So basically, each of the elements in one of the sets is assigned to each of the elements in another set. Well, once again, just more specifically, what does that mean? Each bungalow, that's bungalows X, Y, and Z, is assigned to each of the elements in another set to each of the rooms. So that means that each bungalow gets both rooms. So that tells you, okay, that's what you want to look for. You want to look for that all to all. That tells you that you're dealing with the structure. Those are the 2 structural sets, because it's just a lot easier than to deal with putting the rest of the elements in there. And likewise, if you're told that you're selecting from a particular set, then that's the movable set. So here you know that your tourists are going to be going into these rooms. And since you're not told, well, it's easier, like I said, to look for each to each. Since you're not told that all of the tourists go to all of the bungalows, for example, but some of them go to all of the bungalows, some of them are going to be in each bungalow, you know that the tourists are your movable set. And excuse me, additionally, if any of the sets has a sequential relationship between its elements, then you know that it's a grouping set, with the groups being sequence. So whenever you see sequence, that virtually all the time, that lets you know this is a structural set. You want to put that across the top. And like I said, you can have either 1 or 2 of the sets be in sequence, or be sequential grouping sets. Those are the possible variations. So either none, 1, or both. Both grouping sets being in sequence is the most common variation, followed by none, and then just 1 set. So actually, for most of these complex structural games, most of these complex structural games are going to have your structural sets be, both of them have some sort of sequence. So when you also want to be on the lookout for that. When you see that, you know that you're dealing with a structural set. And one of the grouping sets is the columns, and one is the rows, and the elements from the movable set go into their intersection. So that's what I've been talking to up to this point. You make a grid. Your columns are a set structure, and your rows are the other structure, and you put the movable elements into that grid. And the labels for the columns and the rows are elements from those sets. So this is how you know it's the each to each, because each of the bungalows, so these are the bungalows, so bungalow X gets each of the rooms, so rooms 1 and 2, so X, Y, and Z, 1 and 2. Those are the labels. So the labels for this, for the structure, for the columns and the rows, actually come from the actual sets, because the bungalow set is X, Y, Z, the room set is 1, 2, and you use those elements as your labels. With respect to their relationship, most games will not have a one-to-one matching between the movable elements and the spaces in the grid. The most common variation actually is where the movable elements are repeated. And in fact, as I mentioned, an entire set may actually be duplicated. So it's generally not going to be a one-to-one. The elements may be insufficient, so you may not have enough elements, you may have to repeat, or they might be excess, you might have to leave some of them out. Another variation, but a minor variation, is where only the movable set and grouping set are presented, but the grouping set actually has subgroups. So that's something you want to be on the lookout for as well. And the subgroup is usually one slot in the group that's reserved for one of the particular elements from the movable set. So that's a variation that sometimes appears where you simply just have what it seems like it's two sets, but actually it's just two sets, movable and structural. But the structural itself, there's a part of the structural which you can think of as a subgroup. So we'll cover that in the exercise as well. And in those situations, the groups tend to have different numbers of slots. Okay, with respect to the rules are similar to the grouping games and combination games if one or more of the grouping sets has sequential dimensions. So either grouping or combination, obviously combination if there's a sequential element to this. And you want to be on the lookout for complex rules that establish relationships between movable elements along with relationships between movable and structural elements. So you will see these more complex rules just because these games tend to be a little bit more complex with more information. Okay, so to quickly summarize, the complex structural games will have you put one movable set into two structural sets, and you'll diagram that using a grid with the top and the sides for the structural sets and the movable set going into the grid. And the grid generally going to be between a 2x3 to a 3x6. The distribution will generally not be one-to-one, with there sometimes being repetition or leaving elements out. And the rules will be similar to grouping and combination games, and conditional rules are actually a bit more common.